Okay, in this last video, we're going to look at the multiplicities of our zeros. And multiplicity would mean that one of our factors is repeated more than once. Okay, so let's look at the zeros on this polynomial. It's already factored here. So here it says that we have y equals x plus 3 times x minus 1 quantity squared. So using the zero product property, we know y would be equal to 0. So now we can find out what our x values are. So here, for this factor, we know x equals negative 3. For this factor here, we know that x would equal positive 1. Okay, but this first factor was raised to the first power, so it only occurs once. This would have what we would call a multiplicity of 1. The second factor here, and again this is multiplicity, I'm going to abbreviate it as mult. Okay. The second factor, since it has a power of 2, means that factor actually occurs twice. It's actually x minus 1 times x minus 1. Oops, sorry. Okay. Which, since that occurs twice, this is said to have a multiplicity of 2 because that factor occurs twice in the problem. So the first one, x plus 3, occurred once, has a multiplicity of 1. The second factor, x minus 1, actually occurs twice. So that means x would have to equal 1 there and there, so it has a multiplicity of 2 because it occurs twice. Okay. Now you say, big deal, so 1 occurs once, 1 occurs twice. What does that actually mean? Okay, well let's look at the graph here. So looking at this graph, I've got that equation in here. I've got x plus 3 to the power of 1 and x minus 1 to the power of 2. So if we look at the graph, here's what the graph looks like. Now we knew we had an x-intercept here at negative 3. So there's 1, 2, 3, negative 3 right there. So we've got that as our x-intercept. And then we know the other x-intercept was at positive 1. And you can see the positive 1 in the graph right there. Well, what happens if we change the multiplicity? Let's change the multiplicity on the 1 to a 2. Okay, so I'm going to go to my y equals. Actually, it was already at 2. Let me change the 2 to a 1. And I'm going to hit graph. That totally changed our graph. But you'll notice that the x-intercept is still negative 3 and positive 1. But here, what happened was the powers changed. If this only occurs once, then I have an x occurring once here and an x occurring once there, which gets me a an x squared overall for the whole polynomial. But you'll notice here that this factor now only occurred once. And see how this now crosses through here? And it crosses through here. If this number here, which in this case is odd, if it's odd, the graph's going to cross through. If it's even, this case, this is even, it's going to touch. Now, both of these, currently I have as 1 and 1, so they both cross through the x-axis. Now, watch this. If I change the power of this first one to a 2, and the power of the second one to 2. So now both of these factors, or both of the zeros, occur an even number of time. Look what happens to the graph. See how it bounces off of negative 3 and it bounces off of positive 1? That's because the powers are even. If I went through here and I changed the power of this one to 3, and I change the power of the second 0 to 3, so they both occur 3 times. Now they're going to cross through on those graphs. So here, see how it crossed through negative 3 and it crossed through positive 1? That's because they're both odd. Now, if I make one odd and one even, so let me change this down to a 2, but I'll leave that one a 3, you'll see what happens with the graph. At negative 3, see how it bounces? But then at positive 1, it crosses. So even powers, if we look at here, if the multiplicity is even, it just touches or it bounces off the 0. And if it's an odd multiplicity, it crosses. So this one will bounce. Okay, this one here will cross through. Okay, so that's the difference between odd and even multiplicity. Okay. Then let's finish this up. What happens if all we gave you was the zeros? So I tell you what the x-intercepts are, and I want you to write the polynomial function in standard form. Okay, so we're just going to work backwards here. We're going to know y equals, well, if we have an x-intercept of -5, then that factor must have to be x minus 5, because remember, if this was set equal to 0, then you would bring the 5 over, it would become positive. If your 0 was 6, then this would be x minus 6. If your 0 was 7, then this would be x minus 7. Remember, these signs will always be the opposite of that. And then to write it in standard form, we need to do what we did on the front page here, which is multiply this all out. So if we do that, again, we're going to do FOIL here, and we're going to get an answer. And we're going to multiply that by an x minus 7. So if we multiply this out, we get x squared for the first term. Your outers is negative 6x, and your inners negative 5x, which gets you negative 11x. And then your final terms get you positive 30. Okay? And that gets multiplied by an x minus 7. So now we need to distribute. So this x squared goes to both. So that gets you x cubed minus 7x squared. Then the negative 11x got to go to both. So that gets you a negative 11x squared and positive 77x. And then the 30's got to go to both here. So that gets you plus 30x and minus 210. And then we combined up like terms for our final simplified answer in standard form. Doesn't look like we have any other cubes, so that's x cubed. Take your squares, combine them together, you get negative 18x squared. Combine your x's, and we get positive 107x. And then your constant is negative 210. So here is your final standard form that has x-intercepts at 5, 6, and 7. Okay? And you would be able to pop that in your calculator and verify that. Actually, I should have enough time. I could probably do that. So let me do this. So this is x to, let's see if I can get this all in here. So this is x to the power of 3 minus 18x squared plus 107x minus 210. And if we hit graph, we should have x-intercepts at 5, 6, and 7, and it looks like it's pretty close to 5, 6, and 7 there. I'll go to my table of values. Let me switch this to count by ones, go to the table of values, and if we go to 5, 6, and 7, you can see that the x-intercepts are 5, 6, and 7. Okay? So that's how you write it in standard form. If you had a 0 that was equal to 0, the factor of that would just be x. Okay? If your 0 was negative 1, then we know that would be x plus 1. If the factor was a positive 2, we know that would be an x plus 2. Okay? So that's how you do this. If a 0 is just a 0, it's just an x. If it's a negative, it becomes positive. If it's positive, it becomes negative. Okay? And then it's just a matter of multiplying all that out. Okay? Hope this helped. At this point, we are not going to do this application question. So let's just ignore that for now.